Hi, let's see the Fourier transform of cosine function. I have already wrote the relation of Fourier transform, and here it's difficult to solve this integral. So let's think to another way to find what can be the Fourier transform of cosine function. Um, let's start from frequency domain. Let's have a look to a delta function from frequency domain to time domain. So for that we will need the inverse of Fourier transform, and the inverse of Fourier transform ft minus 1 of a sino is equal to integral from minus infinite to plus infinite of Fourier transform of the sino exponential of j to pi f t df. Well, this relation can be represented as S of f. So let's have a look on the delayed Dirac function, delta function. So this is our delta function, and we want to get into the time domain. So I will apply this relation. So S of t, which is my sino in time domain, is equal to the integral of delta f minus f0, which multiplies exponential j to pi f t df. Well, what's a property of multiplying a delta function with a function? It's that the function gets the value of the delay. So that will be integral from minus infinite to plus infinite of delta function exponential of j to pi, and as I said, the function gets as the value of the delay t df, but this value it's a constant, so it goes in front of the integral, and I can write here j2 pi f 0 to t, minus infinite plus infinite of delta f minus f0 df. And a property of a Dirac of delta function, it doesn't matter. It doesn't matter if it's delayed or not. The area of a delta function is always 1. So my final value is exponential of g to p pi f0 t, which now it's no more a constant, because we are now in time domain and our variable is t, so we have a function. And if I got this result by using a delta function delayed by minus f0, for delta function delayed by plus f0, I will get the value of exponential minus j 2 pi f0 t. Well, if I make a sum of both functions, so exponential g 2 pi f0 t plus exponential minus j 2 pi f0 t. Do you remember the Euler formula? So this is the Euler formula. So this relation is equal to 2 cos of 2 pi f0 t. So if I apply a Fourier transform at both sides of this equality, we will have Fourier transform of this relation is equal to Fourier transform of this cosine function. But both values here coming from inverse of Fourier transform here. So I can write ft Fourier transform of ft minus 1 of what? Of Dirac, of delta function, minus f0 delayed by f0 plus inverse of Fourier transform of delta function plus f0. It's equal to Fourier transform of 2 cos 2 pi f0 t. But what's ft of ft minus 1? It's 1. So I can write here ft of ft minus 1 of delta function minus f0 plus, because they are linear, ft, I don't need ft here plus f0 is equal to Fourier transform to 2 times Fourier transform. I moved 2 in front of Fourier transform because it's a constant. We can perform this kind of action if it is a constant. And the Fourier transform of Fourier transform and theirs, it's 1. So we got the value of delta function delayed by minus f0 plus delta function delayed by plus f0 is equal to 2 Fourier transform of our cosine. So that's the final value of the Fourier transform cosine. Fourier transform of cosine sine it's equal to delta function delayed by minus f0 plus delta function delayed by plus f0 divided by 2. Thank you.